In this video, we'll take a look at how to use the TI series calculator to make a normal quantile plot. In section 6.6, we will be taking a look at sample data and assessing whether we think the sample came from a normal population or not. There are two ways that we do that. First thing we do is to create a histogram, and that histogram should be roughly bell-shaped, and we've done this in previous sections. Then we check for outliers. There should not be more than one outlier present. And we make something called a normal quantile plot. So what that is, it's a graph of points x, y, so it's a scatter plot, where each x value is from the original set of sample data, and each y value is the corresponding z-score that is a quantile value expected from the standard normal distribution. Alright, so what we really want to be able to do is interpret. So let me scroll down. If our sample came from a normal population, when we graph the histogram, it will look roughly normal in shape, roughly bell-shaped. It does not have to be perfect. And then our normal quantile plot, the pattern of points should be reasonably close to a straight line, and they shouldn't show any systematic pattern that's not a straight line pattern. So examples that are not, if our original distribution is uniform, that means that all the values are the same. You'll get a pattern in your points on the normal quantile plot that aren't linear. Notice these, they start down here, there's a portion above, a portion below. There's some sort of a pattern in here that's a little bit more wavy than a straight line. If you have a skewed population or a skewed sample, your histogram looks like this. This one is skewed to the right because that's where the tail is. And then notice that in your normal quantile plot, the values don't end up looking like a straight line at all. There's a bunch of them clumped over here, just the same way that they're clumped over on this one. So we're going to see now how we use the calculator to make that plot. So we're going to take a look at earthquake magnitudes. We are considering just a sample of 5, and we chose the sample 0.7, 2.2, 1.64, 1.01, and 1.62. So with only 5 values, a histogram is not very helpful in revealing distribution of the data. Instead, we're going to go ahead and construct a normal quantile plot. So on our calculator, we turn it on. First thing we do is enter the data in list 1. So we go to Stat, Edit, and we're going to enter our 0.7, 2.2, our 5 data values, 1.64, 1.01, and 1.62. And again, these are just a random sample of 5 earthquake Richter scale values. Then we're going to, I do need to make sure we don't have any functions listed in the y equals key. So we're done here. I'm going to go ahead and quit. Press y equals. You want to make sure you don't have anything in here. We're going to work with the statistics plots. So we press the second key and then the y equals, and that accesses the stat plots. We're going to graph using plot 1, so we'll click enter. What we do first is we want to make sure the plot is on, so we make sure that our cursor is there, hit enter. And then under type, select the last option. This goes through scatter plot, line graph, histogram, box and whisker plot. This very last option right here is what we want. So we go to type, use your arrow keys to get to the last option, click enter. That's a normal quantile plot. Our data list is in list 1. So we're set on there, and then data axis, let your calculator choose, and then the type of mark that you want. A little square is just fine. Then to graph it, you don't have to worry about setting the window. To graph that, we're going to press the zoom key, and option 9 is zoom stat. It will automatically fit the window so you can see. So we click on zoom, scroll down to option 9, zoom stat, click enter. And there's our normal quantile plot. Remember that x are the actual data values, and then the y's are the z-scores that go with the cumulative data. So all we really need to look at, though, to interpret is that pretty much in a straight line overall? And is there any strange pattern that's not linear? So our interpretation is the points appeared to lie reasonably close to a straight line, and there does not appear to be a systematic pattern that's not a straight line. So that sample of 5 earthquake magnitudes appears to come from a normally distributed population.